Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping. I'll be your host once again for today's episode. Thank you for joining me. Today it's just me. I'm going to go over a couple tips and tricks that I just want to be sure that everybody is aware of. And then we're going to jump into a couple case studies for vehicles that I've dealt with doing the mobile diagnostic thing. So first couple things I want to talk about, kind of like a public service announcement, I guess, just things that you're probably aware of, at least I would hope, or that was kind of the reason I brought this up, is I thought most technicians in the field that had some experience were aware of these things if you're doing diagnostics on vehicles for any period of time. But clearly, based on the things that I run into or getting calls for into shops, technicians are not aware of these. So if you are, awesome, this is a refresher. But if you're not doing these things, making your life easier, much easier, please do. And also let everybody else know, right? If you know somebody who's not aware of this, maybe they're new, maybe they just haven't, connected these dots yet, help them out. There's certain things where it's kept real close to a person or technician's chest, right? A secret tip or trick for doing a specific job. And I get it in some cases, right? There's some high level advanced stuff where the way to get that done is kind of a secret, and you've put some work into figuring out how to do it. And maybe once you figure it out, it's easy to do, and it's not exactly shared with everyone or publicly. These are not those types of things. These are processes that everybody should know if you're a professional in this field. So anyways, enough talking about it. Let's get into the two that I'm referring to. The first one is if you have a misfire on an engine, one of the very first things that you should do is crank the engine over in a clear flood state or with the fuel injectors disabled somehow. Okay, so depending on the vehicle, you might have to unplug some injectors or find a fuse, whatever that might be. But in a domestic vehicle, you're going to do a clear flood, putting your foot all the way down on the accelerator pedal and cranking the engine. And it won't start. It'll crank, but it won't start. And we're going to listen to the starter turning over the engine. That's it. It's that simple. Why I'm bringing this up is multiple times in the last couple months, I'd say probably 4 or 5 times, I've come into a shop. They have gone after a misfire. They have replaced plugs, coils, injectors, or swapped around, maybe not even replaced in some cases, but swapped around these parts, and they still have a misfire. And usually at this point, they're considering a PCM, and that's why they've called me, because they want to be sure before they put a PCM in it. Or maybe they already have put a PCM in it and they've called me to program it. And even in some cases, maybe a compression test, right? It's not that they skip it, it's last on their list of tests. But the thing about engines nowadays is, unless you're paying attention, you may not know what good compression is, right? 140, well, that seems like a good number. Well, is it for that particular engine? Is that engine supposed to be pushing 200 for compression on that cylinder, and you didn't check the rest of the cylinders on that engine, or you didn't find the service information specification, if there is one, and so you think 140 is good? It might not be. But here's the deal. Here's where I'm going with this. And we could do a relative compression test with the scope. I'm not even talking about that yet. All I'm talking about is cranking the engine over and listening to it, and you will identify these compression problems very, very quickly. It's super, super easy, right? And it's, again, if I have a misfire it's one of the first things that I'm going to do. And at that point, I'm kind of done. Not necessarily, right? Maybe we want to figure out exactly what's causing the compression issue. And you also do want to be careful of a washed down cylinder where too much fuel has entered a cylinder and washed all the oil off of the cylinder wall, so you can get low compression from that. But for a lot of engines nowadays, and it seems more now than ever before, in my experience in the automotive field, we've got mechanical misfires from valve train issues. And I mean, could be piston issues as well, but definitely valve issues on a lot of vehicles. And we're able to identify this super easy by cranking the engine over and listening to it, right? You're going to hear that skip as the starter is turning over the engine. It should be very rhythmic. It should be the same on every cylinder as that starter is pushing against the compression stroke on each cylinder. They should all sound the same. And if one doesn't, you got a low cylinder, right? I'm not explaining anything that you don't know. You're probably aware of this. But again, the fact that shops aren't doing this, that they went through the hassle of swapping a plug, swapping a coil, swapping an injector, putting a PCM in there, even doing a compression test, like taking the time to get a gauge out and cranking the engine over that way, and they haven't listened to the way that it cranks, you're missing out on a super, super easy test if you're not doing that. Now, you're not going to pick out every compression problem this way, and that's where scope can come in handy. And I have episodes out on stuff like that, and there's a lot of material out on relative compression and pressure transducers. That's a little bit more advanced, but I'm saying most of the compression issues that you come across on engines, you can hear them with almost no testing equipment needed. Like, you don't need a fancy scope. You don't need a fancy scan tool, although Fords will do a relative compression test through the scan tool. But this is just cranking the engine over and listening to it. And I don't know how many times I go into a shop, and that's the first thing I do when these guys have been, tracking down a misfire for half a day. And I kind of look over at the technicians as I'm cranking it and goes, rah, 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 rah. And I'm just like, that's all you got to do, man. It's so easy. So anyways, I'm not trying to dog anybody. I just want to make sure everybody's doing that because it's so simple and it's overlooked by a lot of people. So anyways, that's first one. Second one that I wanted to bring up that I think is really, really helpful, and I'm sure most of you are aware of, is using your scan tool to your advantage when it comes to electrical circuits. Okay, so here's what I mean by that. If there's a computer-controlled circuit on the vehicle, which there's lots, and there is a code setting in reference, right? You're chasing down that circuit or that sensor, whatever it is. What you want to do, if possible, is use your scan tool and the computer in the vehicle to your advantage to assess the circuit. Okay, this is going to save you a lot of time. This will bypass your flow charts in a lot of cases, although I will show a quick example of where that's not the case always. But it's going to eliminate the need for extensive testing of a circuit if you understand how to use your scan tool. If you understand the circuit, you understand electricity, you can make life very, very easy for yourself. Again, you might be aware of this, but I just want to put it top of mind so that everybody is actually taking the time to do this. So, quick example here, just to illustrate what I'm talking about, if that doesn't make sense. This is the old traditional, one of the first ways I was introduced to using a scan tool in this way to help you through a diagnosis. Okay, a thermistor circuit, right? So an engine coolant temperature sensor. Let's say we got a code for it, or it's not reading right, whatever. We've got a PCM, we've got two wires, a ground and a signal wire going to a thermistor, which is bolted up, threaded into the water outlet housing, right? And it's just a resistor. PCM sends out 5 volts on one side. We're going to drop voltage across a fixed resistor in the PCM, and then we're going to drop the rest of the voltage across the thermistor, right? That's, you guys know how a thermistor works. But in order to assess the PCM and the circuit, we can do this very easily by connecting our scan tool, pulling up the data PID for this thermistor, for this engine coolant temp sensor. And it might be voltage, it might be temperature, doesn't matter. We can use them the same way. But we're going to go to that coolant temp sensor. We're going to unplug it. Now, as soon as we unplug it, we should see it drop down to -40. That's the expectation, because an open circuit on one of these thermistors means cold temperature. So resistance goes up, temperature goes down. That's how these circuits operate. That's my expectation. Because I know how the circuit works, I know how the PCM should respond, I'm expecting to see -40 when I unplug it. And then I'm going to take those two wires on the harness side, and I'm going to take a jumper wire and jump the two of them together. And I should see the temperature go the other direction, right? To the max, whatever it is, 270, 240, whatever the maximum temperature is for that particular circuit and application. I should see it go the other way. And, you know, depending on the accessibility of the connector at the coolant temp sensor, this test takes me maybe 5 minutes to do. And what I've done is assessed both wires going from the PCM to the sensor and the PCM's ability to assess the circuit properly. Okay. And then if I have a problem, guess what? It's in that sensor. And again, very common example. Most of you are aware of this. But what I'm doing, especially with a scan tool that's Bluetooth, which most of them are now, I'm doing this all under the hood with very little testing equipment and very little time. I'm using the computer's ability to assess a circuit and my understanding of the circuit and the scan tool to make real quick work of this, okay? But this is not the only application that we can use this in. The more circuits that we understand, and the better that we understand electricity, the more often that you can use this, okay? Another real quick example here, I had a '07 Tundra with a O2 sensor circuit code, and I was able to go into the data stream. Now, this one was helpful because it actually had the impedance value of the sensor along with the voltage on the signal wire. Well, the impedance read 0. So not OL, not open, but 0. And it had 0 volts on the signal wire. When I saw that, and I compared it to the other side too, which had a much higher impedance value on the sensor. When I saw that, I was thinking, okay, this has to be a short to ground, right? Because I understand how these circuits work. You know, I understand what doing an ohm check would get me if I were to assess the circuit the same way the computer is, right? And this is the thing, is the computer's already set up to assess these circuits. Why not use it to our advantage, right? And so what I did was plugged in the scan tool, graphed those data PIDs. I went underneath the vehicle. Let's inspect this sensor. I unplugged the sensor and it didn't change anything. But the impedance value is still 0. So as long as this data PID's accurate, this thing's still shorted to ground. Well, visual inspection helped me out here. Someone had done a repair to the wiring a few inches up from the sensor wire, and they did a decent job with some heat shrink and some soldering, but this O2 sensor wire had a ground shield that went around it. So what that consisted of was the actual signal wire, and then wrapped around it was a bare wire that is grounded by the PCM, and then a plastic sheath goes over that. Well, what had happened is when they did the wire repair, one strand of this wire made its way into the heat shrink on the signal wire and grounded out the signal wire. And it doesn't take much on an O2 sensor signal circuit in order to pull it down to ground. If you've ever done the test on a lot of vehicles, you can pull a O2 sensor, and this is narrowband stuff, by the way, you can pull a O2 sensor signal wire up or down with your finger through your body, right? You can touch the positive terminal and touch the signal wire, and you can see the voltage go up in your scan tool, right? But again, what we're doing here, this isn't about O2 sensors. And I disconnected the strand. There was literally one strand, disconnected the strand of wire, and the impedance value went to its maximum because I had it unplugged. I plugged the sensor back in and it matched the other side. And then, started it up and it started making voltage. But Again, where I'm going with this is we're using the computer's ability to assess the circuit. We're understanding what the computer is doing on a particular circuit. We're using our scan tool, and we're making real quick work of this stuff, right? I didn't even pull out any electrical testing equipment for this one. It was literally the scan tool and my eyes, and that was it. That's all I needed because I understand electrical. I understand what these circuits are doing, and that's where the work behind the scenes comes in, but then relying on the computer's ability to assess the circuit, okay? One more quick example here, and then we'll move on to the case studies. I was working on a push-button Honda, and the vehicle had a keyless entry warning on the dash when you go to start this thing. And it worked, it started, but this warning message would come up, check the code, and it has a circuit code for the rear interior antenna for this vehicle. And if you look up in this flowchart for this code, and I always glance through the flowcharts, although I don't always use them, I thought this one pertained exactly to what we're talking about. What it has you do, if you get this code, the circuit code for an antenna, there's only 2 wires going to this antenna. It's mounted at the very back of the center console, and you access it from the rear seat. You pull a panel back. There's this little antenna, 2 wires. It has you access this antenna, unplug it, and short the 2 wires together, and you should get a shorted circuit code. And I should mention, the original code was open. They're saying, jump it together, and you should get a shorted code. Why is that? The exact same reason it works with a thermistor. And Honda's flowchart is having you do the exact same thing. So again, we don't even necessarily care on this particular application what's supposed to be on each one of those wires. If we jump those together and it says shorted, we know the circuit's good all the way back to the control module that's involved with this antenna. And then it's an antenna that's a replacement. In this case, it didn't. I jumped those two together. I still had an open circuit code. Well, it turns out somebody had the center console up at some point, and there's a connector. If you go straight down from the shifter, there's another connector here for this antenna. Somebody left it unplugged. So that was the next thing I did. Went to the next connector, and I found it. But anyways, what I'm getting at there is not all flowcharts are ohm checks of the wires, but you do see that a lot, right? That's the test a lot of the times in flowcharts is ohm check these 2 wires from the module to the sensor. Well, you don't have to. If you understand how these things work, you can do a real quick check by seeing how the computer reacts to manipulating the circuit in a certain way. And there's lots of variables depending on what you're working on and the application. But man, does that make your life easy. Using that scan tool, using that module's ability to assess the circuit to your advantage, and you can get through some problems very, very quickly this way with very little testing equipment. And don't get me wrong, I'm not advocating don't test stuff. That's not where I'm going with this, but make your life easier, right? Don't make it more difficult than it needs to be, because these systems have been set up in a way to assess themselves in a lot of cases, and we can use that to our advantage. All right, so enough of that. Let's do a couple case studies real quick here. These were interesting vehicles that I've had over the last few weeks. The first one was a 2015 Land Rover, Range Rover. I don't know if that's the way you're supposed to say it, but it was a Range Rover Evoque. This is a 2.0 turbo front wheel drive vehicle. Basically a Ford Escape is what I kind of came to find out. I never worked on one of these things before, but the more I did work on it, I'm like, well, this is just a Ford Escape, but they slap a Range Rover sticker on it. I'm sure charge way more money. But anyways, the shop had just replaced the turbocharger in this engine. And after the fact, they were getting a P0234, which is an overboost code. They said they replaced the turbocharger because they had underboost codes before. I didn't confirm that myself, but now they're getting an overboost code consistently after turbocharger replacement. Okay, so I'm going to test drive this thing and verify that this code sets, and it does. Every single time you go to hard acceleration in this Range Rover, you get an overboost code. Now, the thing pulls, it moves, it's got boost for sure, but it sets this overboost code every time you go to accelerate with it. You got to get heavy on the pedal, but it will set this overboost code every single time. All right. I looked at some data PIDs. I could not for the life of me find a desired boost data PID in this thing. So I don't know if it was my scan tool. I don't know if I missed it. Maybe it's labeled something that I'm not familiar with. I use the search feature with the data PIDs. If you're not using that, use the search feature. It's in the top right hand of most tools. TopDon does it. Autel does it. Put in turbo, put in boost, put in pressure. And I did all of that. And it's a really good way to sort through your data PIDs and find what you're looking for. But I could not find a desired boost PID for this thing, just the actual, right? And I wanted to compare the two to see when are we off, how far are we off. Well, I couldn't find it, but I do know this thing's setting a overboost code every single time. All right, so go back to the shop. I'm going to do a little bit of research on this before I do any testing to make sure I'm familiar with the system and how it works, right? Because I don't work on Range Rovers very often. So first thing I found was this P0234 can set after turbocharger replacement if you fail to do a reset of the ECM adaptives. And there's notes in Identifix where people would have this situation after a turbo replacement. I'm like, okay, well, maybe this will be a slam dunk. I performed this. I was able to do it with the Autel. No change. Still every single time I set an overboost code. Okay, so we got an actual problem here. It's not an adaptive memory situation. Okay, now I need to really understand how this turbocharger works before I start assessing the components that are involved. And first thing on my list that I want to understand is the wastegate on the turbocharger. All right, so the wastegate, if you're not familiar, is basically a valve that allows exhaust pressure to bypass the turbocharger or go through the turbine for the turbocharger. And that's going to change the speed of the compressor and change the boost output of the turbo, right? So if we have that wastegate closed, we're going to get maximum boost pressure. If we have that wastegate open, we're going to get little to no boost pressure out of this turbocharger, right? And if this wastegate is staying closed when it's not supposed to, for whatever reason, that's how we could get an overboost code. So it's important for me to understand how this works, how it's controlled. Well, first thing that I want to note about this vehicle, and this is where it reminded me of a Ford. That's because I've had some Fusions recently where it's set up exactly the same as this. The wastegate on these Fords is normally in the open position. Now, I would say traditionally, for me personally anyways, the vehicles that I'm used to working on with turbochargers, I'm going back a little bit here, but they'd be normally closed, right? And then boost pressure would actually open the wastegate in order to allow exhaust gases to bypass. But this one's normally open. And in this situation, what Land Rover is going to do, and what they do in these Fusions as well, is they apply vacuum to the wastegate in order for it to close to apply boost pressure. So again, traditionally speaking, if you, in a normally closed wastegate, you could remove the line from the wastegate that would apply pressure normally, and you get full boost. Well, in a normally open wastegate, if you were to disconnect the line and go drive this thing, you'd have no boost. That's how, and there's a big difference there, right? You need to know what you're working on. Is it normally open or normally closed? Well, this one should be normally open and has vacuum applied to it in order to apply boost pressure. So right now I'm thinking, okay, well, there must be vacuum being applied to this thing in order for it to overboost, right? To make boost in the first place, it has to have vacuum. And where's this vacuum come from? It comes from a vacuum pump that's driven by the camshaft on the back of the head. But I'm really not worried about that vacuum pump right now because I'm getting boost pressure. So it must be working, right? Okay. Well, how is it regulated? How and when do we send vacuum to this wastegate? There's a control solenoid on the front side of the engine that regulates this vacuum to the wastegate. It's controlled by the PCM, and it's either going to send or not send vacuum to that wastegate, right? Send vacuum, we're going to make boost. Cut off vacuum, and that thing will go to the open position. We won't make boost. Okay, so easy. Let's check this out. I do notice the solenoid is brand new. And I asked the tech, he's like, yeah, we replaced that. Okay. I wasn't told that up front, but that's fine. It's a brand new solenoid. Now, it doesn't mean it's good. So I'll do my tests. I activate this thing and we have vacuum flowing through it. I unplug it and it's completely blocked. There's no vacuum going through it. So it's a normally closed solenoid and it seems to be working the way it's supposed to. So something's not quite clear here because my vacuum pump's working. I did measure the vacuum out of it and my solenoid appears to be working correctly. So either there's something up with the turbo or the PCM's command is incorrect. So what I did in this case is I decided to unplug the vacuum line that goes to the wastegate and I want to go drive this thing. I want to see what happens. Am I going to have no boost pressure or am I still going to be in the overboost condition? Well, when I did this, right, so I'm disconnecting my vacuum line from my wastegate, eliminating the control system from the vehicle and eliminating any potential vacuum from getting to this thing. I still have boost pressure, like all of the boost pressure on this thing. So I know there's something up with this turbo that they put on there. Okay, let's get this thing up in the air and check this out. We put a vacuum pump right to this wastegate and we applied a vacuum. We watched the rod. It didn't move, didn't change position at all. And this is the flap that opens and closes for pressure to bypass the turbo. I tell them, okay, let's switch this over to pressure, right? It's one of those little Mighty Vac pumps where you can do vacuum or pressure. We apply pressure to the wastegate and we see it open. Okay, so this wastegate, or you could say turbo, the wastegate is incorrect for the application for this vehicle. I don't know where they got it from or how they got one that was incorrect. I'm actually, now that I'm thinking about it, I wonder if they got it for an escape, because I know some of those escapes were normally closed wastegate. Whereas this one is supposed to be normally open. And that's what this one is, right? If you apply boost pressure to this particular wastegate that's mounted to it, that wastegate opens up and it will reduce the turbo output. But this system's not designed that way. This system is designed to apply vacuum in order to make boost. So the complete opposite. I just told him, okay, well, you got to get the right turbo on here. He's like, well, can we swap over I'm like, I don't know, dude. Like, if you want to mess around with that, it seems like a waste of time to me, but they'll figure that part of it out. I got my portion of the job done, identified the component that's causing their problem, and I'm moving on. So anyways, important to understand if you're going to be dealing with turbos, how the system works on your particular vehicle, and then you can do some testing to assess what's going on. All right. Last vehicle here, 2012 Chevy Malibu. Actually, the same shop called me for a misfire. They had already done a number of tests to this vehicle. They had swapped / put in some new plugs and coils on this vehicle. They had swapped an injector and they had done a compression test. And everything they came up with was good on this cylinder. I guess they didn't do a whole lot of testing besides the compression test, but the Swapnostics, right? That's on a 4-cylinder engine. I'd probably do the same thing on plugs and coils. Let's swap some stuff around and see if the misfire moves. But they've got a misfire in cylinder number 4. And so this is just the 2.4 Ecotech, a very, very common engine. Most of us have worked on many of these, but they keep getting a misfire on cylinder number 4. And so they called me in. Of course, I want to verify all of this stuff, even though they've swapped stuff, they replaced stuff. My process has to be, I check everything like I don't know anything about the vehicle. Otherwise, if I rely on something that's been changed or swapped, well, maybe it wasn't, maybe there's some other issues. I'll miss something. So I'm going to go through, I'm going to test everything. But first thing I want to do is let's verify the concern and get it to miss. And this is where it was a little bit interesting because I really couldn't get it to miss in the parking lot. So I went out and drove this vehicle, and the only time I could get it to miss, and it was consistent every time I did this, but it was on acceleration. And not in a straight line though. Although I did get a few random misfires on acceleration. sometimes you do on any engine, but where it really stood out, where it was really noticeable, is when I was taking a corner and accelerating, right? So you come to a stop at an intersection and you accelerate as you're turning to the right. My test drive route for this particular shop has all right turns. I try to make all my test drive routes right-hand turns just to avoid driving a customer vehicle and taking a left turn. Not that I can't take a left turn, but anyways, it was all right turns. And every single time I would accelerate and go to the right, I'd feel this misfire, and it would count on the scan tool as well on cylinder number 4, just like they were saying. It was interesting because it didn't feel like an ignition misfire, right? A lot of times when we see misfires under acceleration, they're ignition related, and there's a feel to an ignition misfire. I'm sure most of us have experienced it's that like fish bite kind of jerking feeling. It just has a feel to it when it's ignition misfire. This did not feel like this. The way I would describe it is it was lighter, and I don't know if that really makes sense, but that's the best description that I can come up with. It just didn't feel like an ignition misfire. Doesn't mean it isn't, but I just noticed that on the test drive. Okay, well, let's bring it back to the shop and let's do some testing here. Of course, like I mentioned, any misfire, well, let's crank this thing over and listen to it. And I did that, and it sounded great. Doesn't mean it's perfect. Maybe we'll do a relative compression test to verify, but it sounds perfectly even cranking. Okay, so I don't have a dead hole anyways. And I may go in cylinder to do some testing to assess what's going on, but just an ear check, this thing sounds pretty good. So I'm going to go through and I'm going to check all my other components, right? And I actually did a little swapnostics myself. I moved a plug, I moved a coil, same thing, didn't change anything. And I can kind of just get away from ignition at this point because, again, it didn't feel like it. Okay, next test, we'll do an injector balance test. Just to see, okay, are the injectors flowing the same rate across the board? And they were. They were all even for the drop. And GM makes this real easy. You can do this through the scan tool. Just pop a gauge on there. There's a Schrader valve on the rail for these old ones because this was not direct injected. It's port. Okay, they all flow the same amounts. And they said they swapped the injector, so I guess I'm not really thinking injector at this point either. So what am I left with, right? Again, maybe we could look a little bit closer at the compression for the cylinder and see what comes up there. But I'm also thinking, what does the right-hand turn have to do with this? I'm kind of racking my brain. I'm like, is this a circuit issue, right? Something is coming disconnected as the engine's shifting. That's a possibility. I don't have any codes for it, right? If you have a circuit become open on a fuel injector, you get a 200 code for it pretty consistently. I know on GMs at least, you get a code for one of these things if it unplugs or the circuit becomes disconnected. Again, didn't think it was ignition, right? If the coil is becoming disconnected, again, think you'd get a circuit code for that, but it didn't feel like an ignition misfire. Now, at this point, I was doing my fuel injector balance test, and I had just done a podcast with Fonslow where I was talking about a single cylinder misfire from contaminated fuel. And it just so happened to be a cylinder that was at the end of the rail. Okay. Number 4 is at the end of the rail on the driver's side of the vehicle, right? It's a transversely mounted engine. So number 4 is the furthest over to the left of the vehicle or the driver's side of the vehicle at the end. And it's misfiring on right-hand turns. Okay. So where am I going with this? I was like, I need to check the fuel quality, and I already have my fuel gauge hooked up, right? All I have to do is hit a button, and I bought a glass graduated cylinder for my van because I do so many fuel quality checks. I get the fuel into the graduated cylinder, and this fuel is cloudy and contaminated. I'd almost call it milky. I don't know what was in there. It didn't really look like water, but you could not see through the gasoline, right? It was yellow. It smelled like gas, but you could not see through it. It was cloudy, and I let it settle for a while. I actually grabbed 2 samples because I was worried that maybe there was some old fuel that was in my gauge. And all the samples looked the same. It's just like this cloudiness to the fuel in the vehicle. So what was happening was the contamination, or I don't know, again, I don't know if it was water or what exactly was in there, was being forced to the end of the rail. And it was amplified as you were cornering the vehicle, and momentum was pushing it over there, which is pretty interesting. You don't run into that every single day. But I told them, I was like, drain the tank, fill it up with fresh stuff. It had about a quarter tank of gas in it, and this should take care of the misfire. Call me if there's any issues. Well, they did that. Misfire was gone. This thing ran great after the fact. It was a little bit of luck, honestly, that I had just been talking about this with Matt not 2 or 3 days prior, that it popped up in my mind. And sometimes stuff like that works, right? I might have taken, well, no, I would have definitely taken longer to get to that conclusion had I not been talking about it just recently, but it was top of mind, and I had my fuel gauge connected. I'm like, you know what? I better just check and see. And that gave me my answer. So sometimes we luck out on some of this stuff, but also it's about exploring possibilities, talking with other people, seeing what else is out there, and it builds your scope on what the possible failures are for particular problems. And that definitely helped me out here. But pretty interesting contaminated fuel single cylinder misfire. Was there misfires on other cylinders at times? There probably was, but I didn't drive this thing enough to really assess that. I just know number 4 was the consistent misfire that was popping up a lot. All right, that's going to do it for today. Thank you for listening to the podcast. I really appreciate it. I enjoy getting to talk with the listeners to the show, the feedback that you have, the things that everybody has added to the show, the people that have been on the show. And hey, maybe that's you. You want to be on the show? You want to be a guest on the podcast? Hit me up. Email. It's in the show notes. Facebook, Messenger. I'll get back to you as soon as I can. And maybe we can have you on and talk about the auto industry. But other than that, let's all get out there, start fixing the world one car at a time.